Good afternoon and welcome to the 2020 Fluid Power Technology Conference virtual series. My name is Mike Ferens. I am the publisher of Fluid Power World magazine, and I'd like to thank you for attending this, our 10th installment of the Fluid Power Technology Conference virtual series. Before we get started, and many of you already know the routine here, but I want to go over a few housekeeping items with Hopin. On the left of your screen, you'll see a 3-button navigation. It's a 4-button navigation area. Home is the best place to see if you want to know which of the rooms to attend and which one is live. The stage is where in a few minutes the keynote will be taking place, so you want to click on the stage, which you probably already are. And then there's the button for the Q&A session, which will take place after. And there is a fourth area there that is our feature showcase area, which I would invite you to attend at any time to see videos from our many sponsors. Now, if you look over to the right side of your screen, you'll see a white area that is used for the chat function. If you don't see that, it's probably because you need to use the little caret icon at the top to open that up, and you can follow the chat going on there, and you can also ask questions in that chat area. If at any time you're having difficulty with navigation, please just let us know through the chat feature. You can also ask questions in the chat feature, which we will relay to our speaker today in that Q&A session. So ask your questions during the presentation or in the Q&A session. While you're watching the Q&A, you'll be in the listen-only mode. Once you're in the Q&A, the first 20 people who are in there can turn on their camera, and we strongly encourage you to do that so we can interact with you and you can ask your questions live. Or you can just listen in on a silent mode. Also in that Q&A, in that chat function, you'll see some poll questions that we'll be posting on there early on. I'd invite you to just go ahead and check those out and answer to the best of your ability those poll questions so we can incorporate that into the presentation as well. So I'd like to take this opportunity now to thank our sponsor for this event, Famic Technologies. Since 1986, Famic Technologies has been leading the industry by designing world-class, trade-oriented software solutions in the fields of fluid power, electrical engineering, industrial automation, and custom software development. It has always been one step ahead, especially with Automation Studio, a unique software covering all project machine technologies, including hydraulics, pneumatics, electrical, and automation in order to design, document, and simulate complete systems. More specifically, Automation Studio is the world-leading all-in-one intuitive software solution for increased engineering productivity, a user-friendly platform with access to built-in component libraries to help accelerate design processes. Integrated simulation capabilities make it easy to quickly animate, analyze, and validate systems performance. This innovative design and simulation software is used for training, maintenance, validation, and troubleshooting of multi-technology circuits in mobile and industrial equipment, covering the entire machine lifecycle to optimize workflows and reduce product time to market. Please support Famic Technologies and all of our series sponsors who make this program possible. Hopefully you will be helping us to promote today's session, and if you're going to use social media at all, please use our hashtag FPTC2020. And now I'd like to tell you a little bit about today's speaker. Denis Lenoble is the product manager for Automation Studio at Famic Technologies. He has a master's degree in mechanics and a diploma of advanced studies in fluid mechanics from Pierre et Marie Curie University, Paris 6. Denis accumulated 6 years of experience in teaching as an associate professor of mechanical design, teacher diploma for technical high school. He has also worked in France as a fluid mechanics teacher in the University of Caen, the University of Paul Sabatier at Toulouse, France, and in the Science University in Port-au-Prince, Haiti. Denis started working as a training consultant for Famic just over 20 years ago. He joined the company a year later and is now the product manager for Automation Studio. And it gives me a great deal of honor to introduce today's speaker, Denis Lenoble. So just give me a moment and I will be able to shift over to his presentation. All right, Denis, whenever you're ready, please start.
Okay. So hello everybody. Can I have a confirmation that you can hear me? Okay, I hope so. I think so. We have made some tests, so it's okay. So welcome everybody. I'm happy that you can attend this meeting. The purpose of this presentation will be to demonstrate how we can bring product reliability one step beyond by applying failure mode effect analysis on the digital twin of the real system. So there is a poll with few questions. I don't know if you have time to fill this. It was just to know if you are aware of this failure analysis that is applicable on system. There is different method. The objective is just in the presentation to cover different type of analyze and present the one we have implement in Automation Studio version 7.0. And I will showcase a demonstration. So first, to introduce the subject, we know that industry has to provide efficient method to develop reliable products. So it means they have to minimize productivity loss, they have to maximize human safety, to warranty environment preservation globally to increase quality in their products. In the end of the managers, what they are looking for is they want to have a collaborative, active collaboration between all the departments to maintain productivities and also reliability in the whole product life cycle. So the product life cycle does not mean only the design and the production of the product, but also the after-sale service. Now, the manager has some needs, but of course, the workers of departments, the two main departments that need help also, or need tools, I would say, is the designer department. They need tools as well as determinists as intuitive to design a more efficient system. When I say and when I wrote determinist, it is because we have software, we have computers, and the rule of thumb is not nowadays we have to skip a little bit. Of course, in some area they still work, but globally, if we want to be efficient and reliable, we need to have determinist rules. Intuitive, because we are the tool we have is a software, and all the software should be more intuitive to be easy to use. On the other hand, after sale market, the technical support, they need smarter communication to solve more issues faster on the field. So smarter communication, what does it mean? First, it has to be fast, it has to be accurate, and the objective is just to be able to be autonomous at a certain point to troubleshoot system. In this sense, the webinar scope will be to present this failure mode effect analysis. So I think it is pronounced FMEA in English. I used to say FMEA, but I will say FMEA for the rest of the presentation. Presenting this is to show you how we can increase reliability for the industry that produce product or service, also process. And for the manager, it will help to understand they can standardize with this tool, not only for design, but also for this famous process, which is finally the failure mode effect analysis. And this will be done with our machine knowledge management tools that I used to present for a few years during those conferences. Today it will be about this new module that deal with failure mode effect analysis. So, system failure analysis method, there is few. I'm sure you know most of them. Maybe you are using some of them in your company, or some departments in company are using this. So I just want to recap a little bit about few methods. So we have what we call the cause tree and the consequence tree. Finally, both of those methods start from a failure, and it organizes. I will maybe show this. So they start from a failure, except that the goal of the cause tree is just to identify the cause or the combination of cause that trigger that trigger this failure. So depending on the point of view, you will see what method is more applicable. While the consequence tree is more, there is a failure in the system, we want to know what are the consequences. So this is more useful, for example, in a building. If you have a failure, fire doors that does not close, there is consequence. So these methodologies will be more applicable in such area. Now we have also the cause-effect analysis, cause-effect diagram, which is a combination of the method 1 and 2. After we have the risk analysis, which is the goal is the same. It's just to evaluate dangers, the seriousness of the dangers and the causes, except it's more mathematical point of view. There is no representation like we have seen for the cause tree and consequence tree, but this risk analysis can be used efficiently also. Another method is what we call a reliability block diagram. This method, for this method, the starting point is the failure mode that can occur in the component, and to see the consequence in the system. For this method, the system must be organized in a structured document. I don't want to go into details, but globally, this method, just if you have a system, I have taken a system in oil and gas because we have worked on such area. And if you figure a rig is an entire module represented by this block, and the method of reliability block diagram recommend to depict the system in subsystem and digging up to the component. So I don't want to focus on this right now, but you can see how you can this rig split in power unit and 3 subsystems. We take one of the subsystems, it is split in other systems. The advantage of this representation is you don't need to have any technical knowledge. So for a decision maker, it could be interesting to have a feedback because of this method, with this method. And the other thing is the basic element are those blocks here, that finally I continue just the presentation. This subsystem is detailed here, and this is the basic element. This block we call them reliability block, can be a functional group, but also a single component. And this diagram is read from left to right. On the right side, you have the actuation, and all to actuate this, you need to have all these elements working. So if you have a failure in a check valve in this example, it will be, you will go to this level, you will see a failure here and here and here. So this method is really useful and is one of the methods. Now, the last method I will present, it is the purpose of this new module we have implemented in Automation Studio, is a failure mode effect analysis. It is close to the reliability block diagram in the sense we attach to the component failure mode. The cause of any problem is a component failure mode. This is the principle of this method. And the common aspect with the reliability block diagram is the representation of the system, except that you will see, instead of having a square block and stuff like this, you will see that with Automation Studio, we're gonna deal directly with the technical drawing of the system. So this method, FMEA, has been developed in the 60s in the field of aeronautics and army also. And since this time, it's spread out in various industries. The FMEA method can become quantitative as soon as you introduce the criticality. And this is the acronym. As soon as you develop or you want to support the criticality, the FMEA becomes FMK. So failure mode effect critical analysis. The calculation make it possible to classify the failure mode by criticality. So in all of the methods we have seen, we have calculation, statistics, and so on. But this one, you will see how it works in Automation Studio. The FMEA is a standard method. There is 3 standards that contains finally almost the same thing. What we're gonna follow in Automation Studio by default, I insist on this, it's by default we follow this, but we can configure. We're gonna follow the IEC standard 60812. So prior going in the details, I would like, maybe if it is obvious, I would like to present, to give some definitions, because the key of these methods, all of them are the words, the vocabulary we use. The objective is to standardize the vocabulary for all the people that work together, as well as a designer, but also technical support and the field, they have to communicate with the same languages. So I just recap some words. So a failure, it's a termination of the ability of an item to perform required function. So we experiment every day this. In my example, I have the arm that does not move. This is a system failure, okay? The component failure mode is a manner in which way a component fails. So here we have, it could be something else, but in my example, just to illustrate my purpose, we have the jam piston in the stick cylinder, for example. So it is a component failure mode. So there is a distinction between the system failure mode and the component failure mode. You will see that in the FMEA, the component failure mode is a cause, while the system failure mode that occurs because of this component failure mode is a consequence, an effect, a global effect. Now, we have the local effect. So it is a consequence of the failure directly here. So, for example, the stick does not move. So one of the functions in the system does not operate. Globally, what does it mean? By globally, it means that the operator has to go back to the garage because he can't make the machine work. Because in this sense, obviously, if you can't make the stick work, your excavator is jammed to finalize some work. So globally, you have the local effect and the global effect. Now, the failure cause is I would say the technical aspect that trigger the failure in the component. So it could be arch buttress in the cylinder. We're gonna see some example later. And the detection method is an important word also, is the way the failure has been detected. So for example, in this example, it's visual. Or I mean, the operator manipulates his CAN bus joystick, no motion for the stick. It's not visual, but it's a human feeling because of the command. Okay. Now we're gonna introduce a few words that deals with the critical analysis. So we have seen the detection method is how I detect the problem. But detection now is an estimate of the chains to detect the failure in the system. In my example, it is visual, so it is almost certain. So there is an estimate based on a scale. So in my example, I put 1 on 10, so it's really certain to detect this. The severity is a grading of the failure mode effect on the item operation. So in this sense, it's very high. I can't use my stick, so I can't use this function. So it's very high. It's not completely critical in the sense I can go back at the garage. I mean, at the office with my excavator. So there is a level to specify. As you can see here, this is depending on the context. So it's subjective information. Now we have the occurrence. The occurrence denotes the frequency, the probability of occurrence of a failure mode. So by experience, maybe I have classified as rare this, and so there is a scale. As soon as you have those detection, severity, and occurrence parameter, you can define the criticality of a component of a system failure. So it's a combination. The basic standard recommend to make a product of these 3 parameters, and you will obtain the risk priority number. Okay. So this is the definition that sometimes are obvious, but maybe it is interesting to keep it in mind just a little bit. Now, let's just show you an FMEA applied on a component. So a component is not a system, but depending on the scope, if I make my scope, the focus on a cylinder is a system. And normally, supplier can produce FMEA. I think it's called B10. There is a standard to produce the failure analysis of a component. So I can call it, if I consider my cylinder as a product, finally I can create a FMEA, so an analysis of the failure mode of this system. So quickly, we're gonna see some element in the cylinder. We have the fitting, we have external seals, we have the mounting. So the mounting is the mounting from the cylinder fixed to any frame. So I represent it here. But also the internal mounting. I mean the mechanical slider between the piston and rod inside the body. This slider, it's a kind of mounting. There is a slider link. And also we have the internal seals that isolate the 2 rooms, piston and rod room. If I display a quick analysis, we can see that we have component failure mode. So we can have external leaks coming with these seals, for example, or at the fitting area. There is mechanical failure that can occur between the mounting, between the frame and the cylinder, but also we talk about burst stress, sorry, for mechanical blocking can occur between the rod and piston, the rod, piston, and the body of the cylinder. And we have also internal leaks. It's not a complete analysis, it's just to show you a flavor of what information are inside those analyses. So the component failure mode, we have seen three types. We have the failure effect. So for example, the external leaks, the failure effect, the local effect is a slow motion or a low force, for example. And we have the failure cause, that is, we were talking just a few seconds, the rod seals, the fitting leaks. We have the detection. The detection could be visual, could be, let's figure the cylinder is supposed to maintain a load in extension. We will see that because of this, we have the mass or the load that is going down slowly and slowly. So it is visual. And of course, we have some provision. So there is other information, but it's just to show you, as I told you, a flavor of the type of information. So the provision is just how to avoid this to occur. So we have the same for the mechanical, no motion, it's like sliding or blocked mechanism. We have the detection, it could be a sensor, and we have some provision and so on. And the same for internal leak. So this is type of data, of information that provide FMEA, but we're gonna see into detail what is recommending the IEC standard. So how to conduct FMEA in a system? What I want to explain to you right now is how it is done currently in some company. My experience, I have spent a few weeks in oil and gas company, and I have assisted to this type of analysis. When I arrive in the company, so I stay 1 week in this company. As soon as I arrive, they have already started this FMEA. And after I left, they continue this FMEA, just for you to know. And what's happened during this meeting, I haven't assisted, I was here for something else. And but I have seen effectively a team that was regrouped in a room, discussing, brainstorming with not offline, but a remote person. So I was not aware exactly who was there, but it was engineers for sure. And they were discussing all the day long, discussing about conducting this FMEA. And currently, so the description is as follows. The first thing when you want to conduct a FMEA is first you have to analyze the scope. Do you want to analyze an entire machine, part of the machine? Do you want to focus only on the electrical side, on the mechanical side, both? So the scope must be defined. As soon as the scope is defined, you are able to select a team of experts that for who they are concerned by the scope of the analysis. So as soon as you have this expert team that is that can meet together, they have to organize a schedule and milestone to finalize all the action that they have to close. This action, I will answer them, I will describe them later on. But for sure, it takes time, it takes a lot of meeting, and it takes a lot of expert too. So this is the planning of failure mode effect analysis. After this, what you need is to have as many information as possible on the product you want, at least on the scope of the product you want to analyze. So you need the characteristic of each component, the performance are supposed to be, the operation limit on the component, eventually the B10, so the component failure mode that exists, and of course you need to have the logical connection between components. Once you have this, you need, I was talking just about the performance, the characteristic of the component, but now you have to go at a higher level. You need also to know the performance required for your system. So, for example, if we were talking about the excavator, you want to know the pressure, the range of pressure, but also the performance in terms of speed, of position, and so on. So you need to know all this performance, and also not only during the running mode, the working mode, but also during the maintenance phase, and also during a startup phase, for example, at a really cold temperature, for example. So the more information you have, the best you will be able to conduct your FMEA. Now, of course, like I present you at the beginning, you need to have a representation of your system. You need to know the limit, the boundary of your system, and you have to break down the system in functional group, in basic unit. So if you remember the reliability block diagram, of course, sorry, he is represented here. If you have this technical drawing, it is more, I would say, I mean, for technicians, for engineers, this document is really useful because it knows everything of the symbol aspect of this drawing. So you need to have this system breakdown in functions, sub-functions, and component. When you have this, now you can start at each meeting, you can start to take one by one component failure mode that are known or can supposed to be exist because of documentation from manufacturer, and you have to identify for each failure mode. It is a loop. You have to guess, okay, this failure mode occur in the component, what are the consequences? So you have to identify the immediate effect, global effect on the system. You have to define detection, occurrence, severity, potential cause. So you have to fill a report, and as soon as you have done this, you can, and you have to do this for all these aspects, started at a cold temperature, running mode, maintenance phase, for example. And you have to make a loop on all the failure modes that can occur on a component and on each component. So the idea come at Famic. Why? First, it has been requested by customers, but what method should we offer? We know that this one is well practiced in many areas. There is a standard behind, so we decide, and of course in Automation Studio, the starting point, we have the digital twin that exists. So we have analyzed this, we have encountered people, we have discussed, and finally we have developed a module to answer a question. Why not converting simulation data into objective and intelligible information like a FMEA report? Why team concentrate on security and production decision? So we want to propose to have the objective information managed by the simulation, while subjective information remains in the hand of all the actors. We talk about the experts that are supposed to sit down for many hours to conduct, and many days to conduct during many meetings, FMEA. So we want to help them by providing this tool to speed up some aspect that can be done by computers. So I will explain here this. It's the FMEA Synaptic in Automation Studio. On the top of this slide, or maybe the reverse, everything is in the rectangle is the new module that allows to conduct FMEA. Above this rectangle is something that exists for many years in Automation Studio. Famic develop, as you know, manufacturer catalogs. So what does it mean? We take product specification, we pre-configure the component with our generic component library, elementary components. We implement the performance curve. So we talk about efficiency for pump, opening area for directional valve. We provide them respecting the public information of manufacturer products. And with this, with the manufacturer catalog, we are able to design the digital twin. In this example, I just show an excavator. You will see, for my purpose, I will show another industrial circuit. But the objective is not the excavator here, is that there is a digital twin that can handle many technologies. It could be hydraulic, it could be with electrical control, with external control, CAN-bus, and so on. If it was an industrial system, it could be handled by a PLC, by OPC, and so on. So in Automation Studio, you have your digital twin done with catalog, and what is important, all the components are modeled, including potentially their own failure mode. When I was talking about internal leak in a cylinder, for example, we are able in Automation Studio in a cylinder to declare, not activate, but declare this internal leak could exist. This external leaks at port A could exist. The external leaks at port B, and so on. With other parameters, for all components, there is some specific failure that can be declared also. So the concept is the following one. We have our digital tool. We specify the scope of the analysis. It could be the entire machine, but if it is a partial area of the system, we can conduct the same thing. The objective is to take this digital twin and to subdivide in functional group all the components. Each component belongs to a functional group. Okay. With this, we are able to specify the function of the system. So the stick is a function. The bucket is a function. In this type, in the excavator example, for example. As soon as we have the function, all the function, for each function, we have to specify operational mode. So what is an operational mode? Let's figure I have a light in the room. So the light is a function. The operation mode is to turn on the light, operational mode 1, to turn off the line. It's another operational mode. So this is a basic example, but it is the same for the stick cylinder that move in a direction and in other direction. As soon as we have the operational mode, we can measure automatically their nominal performance as soon as I agree with the design I have done. Once you have done this, the simulation will be able to launch a huge analysis by activating one by one each failure for all components that participate to the system, and for each operational mode. So there is a loop, so you can launch a simulation for a few minutes, few hours, it depends the scope of your analysis. And the failure mode manager will analyze and compare the performance measured during this scenario to the nominal performance. If there is, of course, a loss of performance, the simulator will update or generate a report of the system failure mode. And this system failure mode report will contain, as well as objective information, like performance measured during the component failure mode occur, but also subjective information that has to be filled by experts. What we do with this report, this is the step one. The second step is to use this massive report information to help people in two sides. The designer team to improve their design, just to see if it is reliable to some component failure that you can't avoid during the product life cycle. But also when the machine, the system is sold, after sale, the technician, maintenance technician, technical support, I would say after sale, will be able to grab information from this report in order to speed up the process of troubleshooting the system. So this is the concept, the synoptic. Now, I would talk about the methodologies and I will apply it on the baler press. So the starting point, I was talking to you about this, the modelization of the digital twin. It will be done, so I will just describe it quickly. And we're gonna start by spreading components in different functions. Show you how it works with a video. And then we can start specification of the system function. We're gonna specify the operational mode, and we're gonna determine the nominal performance of the system. Once this is done, we will be able to conduct a failure mode analysis. We're gonna show how to finalize the analysis report, and at the end, how to share information with the field. The field, from my point of view, is where the machine is, where there is a problem that occurs, and we have normally they have phone call from the field that require some help at any office. I mean, so first of all, what is the digital twin? I don't want to take time for this. You know this. Globally, from my point of view, I see many things about digital twin. Each time we show, I read paper on digital twin, they show me, I read there is a 3D. Okay, the 3D is a good thing, but in Automation Studio, the 3D is used for animation. I mean, every part of the 3D are linked to the simulation, but the simulation itself is in the technical drawing that you have in front of you. So the digital twin, I show here a baler press. So the baler press, you will see the sequence moving just to have the understand of this, but the objective is to take some, I have no the word, I'm sorry, but the vegetal, and to compact it into parallelepiped, the baler, S-stack. So this is the objective of this industrial system. We have modeled it, we have done only the hydraulic in this digital model, digital twin. We can recognize, of course, the hydraulic. So we have a pump group, we have a manifold with different pop-up valve, and we have external directional valve plus actuators. So this is a technical representation, ISO technical representation that can be used for design, can be used for technical publication, but that we use also to conduct FMEA. So all this hydraulic system, of course, is designed with manufacturer products. By the way, we have a control sequence. It is an industrial system, so there is a sequence that control the actuation of all the cylinders or motor. If there is, I think there is no motor here. And so this is the digital twin. And we have the instant performance that can be plotted, of course, as usually in Automation Studio. So this is a digital twin. Now, we have to take this digital twin, and the first step is to spread components in functional groups. So the following steps, I think there is 3 or 4, will describe. If you accumulate those steps, it will describe the entire process to conduct the FMEA. Okay, the starting point, as I told you, is the digital twin. So here we have a definition to give. A functional group is a set of inseparable elements participating to an elementary function. So here you can see this is the window that shows all the functional group I have declared. So the POM group is an element that you can replace completely. But if we analyze in terms of ISO representation, the POM group is this object where you have the pump itself. You have here, okay, we have a gearbox, we have an engine, and we have also other pump, we have filters, we have a tank. So if you take out the tank, the POM group does not work. So that's why what I want to explain by defining a functional group as a set of inseparable elements. Okay, so each component in this drawing, the gearbox, the motor, the cylinder, will belong to one of those functional groups. So in the next slide, you will see I will activate, make visible and invisible each functional group for you to see quickly where they are. You don't have to remind this. It's just to reinforce my explanation about the functional group. So here, the POM group will disappear. And you see, I will act on each. You see exactly how it has been subdivided. So the rule to subdivide in functional group, it's a logic. I would say the experience, of course, is enough to divide, to spread components in different functional groups. Okay, so this is the first step. The objective is not to demonstrate Automation Studio. It is easy to do. You just have to grab this component, to drag it here, and it's done. I don't want to show how to do this. Just describe the process. Now, we have to define, as soon as we have functional group, we have to define a function, all the function in the system and their own operation mode. So, first of all, what is a function? A function is a set of functional group participating to an actuation in the system. Actuation is, just to simplify, if we consider the baler press, we have seen we have many cylinders that push, compress, retract, open door. So I use this word because it is more understandable, I hope, and is a set of functional groups that participate to actuation. So finally, a function is a set of components, as soon as we know that a functional group is inseparable elements. So a function is a set of components, and only the components that participate to this function. But be careful, if my scope is electro-hydraulic, I have to consider the push button that participate, the coil, the wires that participate to this function. If I focus only on the hydraulic side, okay, I don't care about the electrical. Starting with this definition, we will be able in Automation Studio to create a function. So we have the press actuation, the get actuation, the ejection. So it is part of function of the baler press. And each function is a set of functional group. For example, in each function here, I'm sure I will have this POM group available, because without POM group, of course, you can't have any flow. So the function can't work. So this is the way to describe, to specify a function. Now, when we have a function, we have to define the different operation modes for which it runs. So, for example, we have, let's figure the ejection. So ejection, eject the haystack. To eject the haystack, I have to I have a first operational mode, which is ejection extension, and we have the ejection, retraction. So here you have, with the green dot, you have the different operational mode. And for each operational mode, we have to define when they are activated, when they terminate, and what are their performance. So this is what we have to define. To do this, I will show you how we can define an automation studio automatically performance measure during simulation. So in the following example, you will see the measurement of performance for two different designs. This will illustrate how we can use this module to help to provide a tool for designers to improve their design. So let's start here. We have a first design. So I just activating this overall performance of the system. We see here the system activating. There is a sequence that is doing 6 times, and we are able with this tool to measure measure the productivity of this system. We have launched only 6 sequences, but we have extended the calculation to fastest, if you want, the presentation. Now we have a second design. We're gonna activate the layer with new pumps, new poppet valve in the manifold, and we're gonna launch the simulation, the measurement of the performance with this button. The sequence is exactly the same. The timing is the same. The scale are both the same. Of course, for the presentation, I have accelerated the simulation because I show the animation during the same time. But you can see here we have a new design that helps to improve the productivity. So the target is not to evaluate, okay, but it will cost a lot more. Of course, it will cost a lot more. We are not in this phase of evaluating the price of my design. It is just to show you that eventually you can improve, manage the evolution of the performance during you are designing your digital twin. This is the first usage of some feature of this module. Now, we're gonna recap a little bit what can be done to improve design. I would say I just want to show you what methods are available for user to improve design. So you can test different design by using layer. You have seen apply visible and not visible this part with the 2 extra pump. You can replace component from manufacturer catalog. You can test and replace as soon as you have to remind that the performance we follow are exactly the public performance of the manufacturer. So we're sure that in real life, and we know that OEM requests some tweaking in some components, so the performance must be adapted according to the new design provided by the suppliers, of course. But you can conduct comparison with different products. You can, of course, as for a long time, you can change the type of oil, the ambient condition, just to start to test the running mode of the machine, but to test also starting at a low temperature and so on. You can, of course, change your line type just to validate. You can change a rigid conduct by hose, changing the diameter in few clicks. So it will be very helpful. And of course, you can use different control solution for your hydraulic design in this example by using our internal control modules or with external control. We have, I think we have presented CAN Boost last year, no, 2 years ago, co-simulation last year, and it exists, of course. And so you can test the power aspect of your system, but you can test also your control aspect of your system. And there is, of course, the evaluation of performance could be done in different point of view. You can just measure the speed, the efficiency of your system by using the variable calculated by the simulator, but you can also consider the performance in an energy consumption point of view or cost of energy point of view. And also, like I have shown, I have presented in the Baller Press, it could be also the productivity. So it depends who is conducting what is finally the target and the scope of the analysis. All the time we return at the beginning, what is the planning of this analysis? Now, we have our system. If you remember, I have selected the design 2. Now, how we conduct failure analysis. So, in order to do this, we have these new modules that allows you, the objective of these modules is to activate one by one each component failure mode in your system, and you have a monitor here that show you, so you will have a list of components. During the analyze, you will see what component failure mode is activated, and you will see the status of your the result of the analyze during it is running. Okay, so the goal, there is no assistance. I mean, you can ask a semi-automatic mode, but if you have 200 component failure mode with a sequence of 1 minute, maybe I guess you're gonna not wait 3 hours in front of your computer. You want to do something else on your computer and get back to the analyze report at the end. But so there is no assistance required as soon as the first steps have been done. You can have a semi-automatic mode. Okay, it's a detail, but you can stop each time you detect a failure mode. The simulator will pause and will ask to you to eventually complete subjective information right now. You can, of course, if you have no time, if you need your computer for something else, you can interrupt and recover your analyze. And what is important also, you can start the analyze at any step of your system. Let's figure you have an industrial system like I have seen it was to build metal injection to build a frame of engine. The sequence was, I think, 3 or 4 minutes. If you want to conduct a failure mode effect analysis on the entire system, it takes time. But if you want to focus on a specific operational mode, that is, maybe if you at the sequence, it has it starts only at the 3rd minute and stop 15 seconds after. You are able to start the analysis by using snapshot that helps you to start only at this time. So you don't have to do all the sequence. So it is an aspect very interesting to avoid to waste time. So I will show you directly on an example. So here we have activated 24 failures. This is the list of failure. I am in the failure manager, and I have activated in this failure manager. So this is the list of the component. Each component has an identification, and now we're gonna launch the automatic failure analysis. So I have of course increased the simulation speed, and you will see so it is one sequence for each failure mode. Okay, the sequence take normally, I think it's 40-50 seconds, and we see dynamically the status. So we can see when we see red, it means there is a problem. If it's green, the component failure mode does not provide any problem in the system. And for some component failure mode, we can have a problem of termination. So it means for those examples, case, we have to get back. At the end of the analysis, we have a report that is shown here, and we have with 24 component failure mode, the system has detected 111 system failure modes. You can classify easily by function, by operation mode, all the failure that occurs in the system, and you can organize the report in the way you want. As you can see, many columns have been completed automatically by the simulator, while some other, which are subjective information, must be complete absolutely by expert. The simulator does not know if a cylinder does not work, that it can affect the environment or people. It's only the expert, because it depends on the context of use. And Some effect, potential cause, for example, depend of the technology of the component. There is a difference between a gear pump and a radial piston pump, for example, motor or any type of technology you can think about. So the simulator does not know this. So that's why we have a part, and I want to focus a little bit on this, how the report is informed. What you see here is an example of the column that are displayed. I will talk a little bit later. So the report completion, during the analysis, it's completed automatically. And after analysis, the team expert should inform this. The type of information that are filled automatically is the function affected, the operation mode affected, the local effect. The local effect can be done automatically, and the performance measure, and so on. So this is, all these data are data of identification or of measurement done by the simulator, while the after analysis is data or information that depends, as I was talking about technologies, about context of use. The thing that is really important, using Automation Studio or not, is to have the same language, adopt a language standardization. For example, to put adjective on a performance, company need to standardize themselves of some words, and use also keywords that depend on the system. We have, for example, excavator, we have some word that came back all the time. We have to keep this for the technician, the designer, or the actor to talk the same language. What is interesting is, with the project done, the digital twin done with the project in Automation Studio, is that each expert can work together, not all together, but independently of them, filling their own information for the electrical guy, for the mechanical guy. They don't have to, the split is already done about the objective information. So they just have to think about the consequence, security, productivity, environment. This is the objective. So we take out the data that are calculation, that are determinist. It's the simulator, while subjective information is the expert team. Now, how we share information. So the objective, as I told you, you can use this module to improve your design, helping the designer team, but also help the technical support and the field. So globally, if a failure occurs in real life, technician should explain the symptom in this standard language, and they have to give the more information they can, of course. As soon as they have described this, you can talk about Automation Studio Failure Report Manager. What he's gonna do is gonna take this symptom, explain them if it is not done in the language standardized, in order to be able to filter, to select all the system failure modes that can be concerned by the symptom they have encountered onto the field. As soon as it is done, it can generate a report of a sub-report of the massive report done during the analysis and send back to the field. So we know that company, most of them use with Excel. There is some other tools, no problem, but not with working with the PID representation. So the objective is just to help people to work in a better way. And of course, we are able also to share the project, the entire project, in the viewer of Automation Studio. So if the technician know how to use Automation Studio, they can work with the project by themselves. Anyway, we're gonna see one example, case one. Let's figure we have a loss of productivity on the field. So of course, the technician on the field will communicate with the Automation Studio user. I don't know how to call it, FMEA manager. This person will convert the words, if it is not done in Automation Studio, and among the 1,100 failure that occurs, it's gonna apply some filter. So let's think the productivity is reduced. We've seen that in the detection method, this is a way of detecting that there is a problem. If there is a loss of productivity, we can't, there is less a stack, so there is a problem. It's part of the symptom. In the report, we have this keyword. This is example of keyword. So we have diminished the potential failure mode that can trigger this problem on the field. After this, we have slow actuators. Okay, we diminish a little bit. After this, can we specify an operational mode? Figure yes. If we, for example, it could be the fast approach or the compressing of something, fast approach, I would say. And at the end, we will get a report that can be returned to the field. And the report can be done in a really clean way, Word, or the output is in the way the user wants. Okay. Another example, let's figure the haystacks are not compact, little loose. We apply the same thing. So we have used the word back quality. It's not a good word, but it works in our example. We have already, from this number, from this number of system failure mode, we reach to 8 failure mode. We can specify operational mode, yes or no. Okay, we have. So we finally, at the end, we have only 3 potential failure mode. In this, what I mean in this potential failure mode, it means we have 3 component failure mode that trigger a system failure that create bad quality in the stacks. So you can see how quick it could be to share information as soon as we have the report completely done in with the automatic analysis. Now, what type of information we're gonna return to the field? But finally, useful information. So in the IEC standard, they recommend some information like this. Recommended action, addressing mitigation. So many information that can be useful. You can add custom information, as I told you at the beginning. We follow the IEC, but we are not limited to the IEC standard. So we can create confirmation diagnostic with hyperlink, with a different procedure. If it is short, you can make a list directly here or hyperlink toward the website, something like this. It depends if you are connected, if on the field they are connected or not. And so on. You can eventually manage the last information date. You can manage the maintenance directly in this report also. So globally, they will receive a list of priority action, fail component. The important things here, they receive like a working order and a prioritization of what they have to do first. And of course, the classification is done according to the context of use. If it is on the rig, do I want to stop my BOP to pull it down from the deep water and lose many million for nothing? Or do I just minimize the productivity during few days and try to find another solution? This is, it depends. Finally, there is no only one list of priority action because it depends what is your goal. Okay. So this is type of things. Just to recap, first, we can measure nominal performance and use it to improve the design of your system, so during the design process. After the design is completed and approved, you can conduct failure analysis on the system by supposing the known failure that occur in most of the components. And after this, you are able, if you are in the field, to send symptom issues. The guy from the manager of FMEA will get back with a sub-report to bring corrective or communicate corrective action and stuff like this. So, of course, you can use this for training and technical publication also. Now, the application, I mentioned mobile hydraulic, mentioned industrial, but we talk about system. It could be partial or entire. You can consider all operational mode or not. You can specify only one operational mode. You can use it for new design. For example, you have system in Automation Studio or not. You want to design a sub-function. You can do it in Automation Studio, or eventually an existing project. You can modify the design, improving in the model you have done, and you can conduct only on this part the system analysis. So you don't have to restart from scratch. Now you can select the component failure mode you want, not all, just one, just the electrical. You can really customize in the way you want. Eventually, Automation Studio does not simulate everything. The vibration of the system, we don't simulate. But what we can consider, the expert can add this system failure mode, and instead of completing only the objective information, subjective information, they have to complete also the objective information, because the vibration does not come all the time from one component. It could be something else. So even not simulated failure can be implemented, added manually, as it is done in Excel currently. And just want to confirm, we don't limit to IEC standard. So brief recap, and it will be the end of the presentation. Benefit for corporation, is that it fits in the Six Sigma tools. There is different tool method to improve quality, reliability, productivity. This is one of the elements. You can improve the decision process to maintain security or productivity, because you have a huge amount of information that has been completed by expert, but also with determinist method. So you can democratize this process. I remember when I was in some shows, each time I was talking a few years ago to FMEA to try to understand better what is this. Most of the time, not most of the time, but frequently, some people go, oh, it's a huge work. It means money, people, resource, and so on. So with this method, doing in the digital twin, you can democratize this process, share it between different users, and you reduce the cost of this process. You can improve your design. So it means you can avoid modification as soon as you have done the system. So you avoid costly modification by the early identification of design deficiencies. Okay, you can improve your method of design by using this tool, and so reinforce the design process, and finally improve the reliability and the safety of your system. You can also help more people. You can help technical support also to improve the way of troubleshooting the system in the real life. Okay, the communication will be more efficient. And finally, okay, for training department, finally, most of the module we use can be used by all the departments in Automation Studio, but this one specifically is more useful for design department and technical support department. So I hope I explained clearly my purpose, and I want to thank you for your attention. And I will let Michael take the end. Thank you very much.
Thank you very much, Denis, for your excellent presentation and update on all of the capabilities of Automation Studio. That was quite an amazing presentation. We thank you for that. And I would at this time invite you to join the Q&A session with Denis by clicking on the home button at the top left and then down on the Q&A session. And you may have to refresh your browser in order to get into that session, but just be patient and we'll get right over there. And you can ask your questions of Denis. And I would invite folks to turn on their camera and their mic and join the discussion live. It's always better to exchange information that way. So I'm going to exit and I will see you over in the Q&A. So thank you very much for attending.
Denis, thank you very much for the incredible presentation. As we have people come in for the Q&A, feel free, those who are entering the Q&A as we move people over, to turn on your microphone and your camera to ask any questions about the presentation or the technology that you would like to. Or if, and it looks like we have some participation in the chat as well. So if you want to type in a question, one of our moderators, Mike, or I think Paul is on, can read that out and then have Denis answer it. So thank you again, Denis. It was great to hear, and looking forward to a great Q&A.
Thank you very much.
All right. Paul,
Hi, Denis, how are you?
Yep.
Hi.
I had a quick question. Can you talk about, are there any different methods to conduct failure analysis, and what are they?
You talk about the method I present at the beginning?
Yes. Are there different methods?
Yeah. To conduct failure analysis, there is only I would say two methods. There is the FMEA by itself, which is the standard. So the name taken is root for in this standard. But if we apply the reliability block diagram, it is a tool that complements the failure mode analysis. I would say the other method, cause effect, risk analysis, is not exactly the same. It depends of the point of view you want to adapt. For example, the cause tree and the failure tree, the point of view, you start from a failure and you want to see all the consequences for people, for example, or you want to detect the cause that can create this failure. Why the failure mode effect analysis is, we don't use the word, but we could say component failure mode effect analysis. It is not in the word, but finally, this standard deals with the component failure mode. So the basic element in a system. Why the other failure? And sometimes people are a little confused, and I used to be confused 5 years ago because of those words, because there is finally a failure mode can become a cause of a system failure, which can become a cause. So there is like I don't know the word in English, but the famous poupée russe that embedded many things. And so the method, the only method that takes this name is really the FMEA. But as you can create calculation on cause tree, you can call it also failure mode analysis, because you identify the cause and you can make calculation on how this failure occurs.
Yes. All right. Thank you.
Okay, you're welcome.
Next question. Can we analyze only one failure at a time?
So if we, thank you to ask this question, because sometimes people ask us if it's possible or not. The standardization, the IEC standard, recommend this method is applicable on steady state and at a failure at a time. This is the recommendation of IEC. But because of using automation or any simulator, the advantage is that you can activate different failure during the analyze. So yes, you will analyze a failure at a time, but during the analyze, you can activate other failure. And I don't want to go into details, but in Automation Studio, if a component is working out of his range, so let's think about his maximum pressure, it can trigger a failure by himself. The seal can broke, and so you can have a cascade effect of the failure. So I would say you can make the analysis on many failures.
Okay. Next question. How can I take into consideration failure modes that cannot be simulated?
So, yes, I mentioned a little bit in the presentation, but of course, as many software, we can simulate. Let me think about, let me think about an industrial process where you have a chemical process. We can simulate this in Automation Studio. But if experts want to focus on failure mode that occurs because by experience they know it occurs, they can add manually this failure mode on the report. So if we can simulate a phenomena, you always can inform the consequence. And in this sense, you return in the old method, not the old method, but the current method where you are sitting in a meeting room and you discuss, you brainstorm. So it can be taken into consideration.
Okay, thank you. And next question, can I apply my own standard for risk calculation maintenance?
Yes. As I mentioned, we follow by default when you use this module, you add this module in your Automation Studio, you will have a default configuration that is 100% IEC compatible. But we know that people want to calculate risk analysis, so they have to make a calculation, a specific calculation. You can add the properties. It could be the severity. We follow the scale of the mobile or iron. But if you want to create your own scale from 1 to 4, for example, easy, difficult, impossible, you have 4 scales, you can completely configure your standard in the way you want.
Okay, great. I have one more question, and anyone who also the people in the room, if you have a question, please just put it in the chat. Last question I have is, can I create my own failures?
Yeah, there is many ways to create your own failures. I would say I don't want to show you how it's done, that it's feasible to create your own failure. You can create your model in Automation Studio. So if a failure is missing, you can add it by using different features that exist. So yes, you can create your own failure, except the one we can't simulate. That's it.
Okay. I don't see any additional questions. So Denis, I'm going to thank you very much for this presentation. Thank Famic for your long participation in our Fluid Power Technology Conference, both the live event and now in the virtual series. You've added a lot of wonderful content to our series, and we thank you for that and invite you back anytime to present once again. And I would remind our audience that this presentation in its entirety will appear on the Fluid Power Tech Conference website in a couple of days. So you can watch the entire thing or parts of it or the Q&A as well.
Okay.
That's it for today, and thank you very much for a great day, and hope to see you again soon.
Thank you, Michael. I'm really happy to have attended this meeting and well organized. Thank you very much, everybody.
Okay, thank you. All right.
Bye.
Take care. Yep. Bye-bye.
Bye.